My study was an investigation into the value of soil enrichment media generated from invasive alien plant biowaste. The South African situation. South Africa is one of the most plant biodiverse countries in the world, and alien invasive plants threaten biodiversity by displacing indigenous vegetation. Furthermore, they deplete water resources. Approximately 7% of South Africa's water is utilized by invasive alien plants. Throughout South Africa, approximately 20 million hectares of land have been invaded. This map shows the intensity of invasion in KZN, with the darker colors indicating a higher intensity of invasion, and white either no data or no record. Additionally, South Africa has relatively poor soil quality, coupled with a reduction in water resources equates to poor seedling recruitment of indigenous species. Soil quality. Basically, soil quality is the amount of organic matter content and associated elements, carbon and nitrogen. Decline in soil quality in South Africa is mainly due to poor land use practices such as overgrazing. Soil loss in South Africa equates to between 300 and 400 million tons a year. With this in mind, we said, why not we take the removed invasive alien biomass and convert it into a soil enrichment media. We chose to produce a compost. A compost is basically a mixture of decaying organic matter used to enrich soils. The basis of composting is to allow organic matter to decompose over time. However, it is important to note that woody and herbaceous material compost at different rates. So the aims of my study were first to screen selected invasive alien plants for soil enrichment media potential by examining allelopathic effects. Secondly was to characterize nutritional value of the soil enrichment media generated from the alien biowaste via chemical analysis. And thirdly was to compare plant biowaste compost with a commercial product via plant growth studies using pea and maize. These are the 4 species that I used for the study. These species were used based on the Working for Ecosystem program, and Litsea actively targeting the species at the time. My species were Tithonia diversifolia and Hedychium gardnerianum, while my woody species were Litsea glutinosa and Acacia podalyriifolia. Screening. The success of some invasive alien plants is due to allelopathy. Allelopathy is basically where certain plants change the chemical composition of the soil around them, making the soil toxic for other flora. Allelopathy was tested by exposing maize and pea seeds to leachates produced from invasive alien plants. This is the basic methodology done for the allelopathy trial. Biomass was collected and crushed. Leachates were produced at 2 concentrations of 20 and 40%. Seeds were then placed in petri dishes and left for 7 days to germinate in natural light. And the following measurements were taken: germination, shoot development, and root length. Please note the key is used in the allelopathy study. Germination. In terms of germination, leachates did not reduce germination in maize. However, Tithonia at 40% did reduce germination. We still use Tithonia to produce a soil enrichment media, as the composting process would potentially degrade the allelopathic compounds. Composting methodologies, basically biomass was collected and shredded courtesy of Litsea and the Working for Ecosystem program, and biomass was compost. Biomass was allowed to decompose and mature for approximately 9 weeks. Biomass of alien species was combined in a 1:1 mass ratio of woody and herbaceous during the composting process. This was done as the woody material would compost too slowly for the nature of the study, and 4 compost combinations were created. Please note this is the compost tea used in the growth studies, with the T's representing the alien enrichment media, with the earth representing the commercial variety, and the control being just soil on its own. In terms of nutrient analysis, T2, which was the Acacia and Hedychium combination, had the highest nitrogen content, with the rest being lower than the commercial. However, in terms of phosphorus, the commercial had significantly the highest phosphorus content. And all treatments had comparable potassium content to the commercial, besides the control, which was higher. Then enrichment media of both the alien and the commercial was combined in a 1:1 ratio with Barrier Red. We used Barrier Red for this experiment, as Barrier Red is a common soil in the Durban area, and it is a relatively poor soil. Seeds of maize and pea were germinated on this media. We used maize and pea, as maize is C3 and pea is a C4 plant. Growth analysis. These are the following growth analysis done. However, I will only focus on these for this talk. Germination. Germination of the against the invasive alien media was determined by emergence of the shoot from the media. In maize, only Tithonia, only T2, which is Acacia, and Hedychium performed poorly compared to the commercial. And whereas in P, T1, which is Acacia and Tithonia, was the only treatment that was comparable to the commercial. Root and shoot growth. This was in terms of millimeters per day. In terms of maize, root growth, T1 was the only treatment that performed poorly compared to the commercial. In terms of shoot growth, the earth had a higher shoot growth than all the other treatments. With regards to P, T1 was the only treatment that was comparable to the commercial in terms of root growth. However, in terms of shoot growth, all the treatments were comparable to the commercial. Growth rate. The growth rate across the treatments was comparable to commercial, except for T2, which is Acacia and Hedychium, or both maize and P. Biomass allocation. In terms of maize, the stem allocation did not differ between treatments. However, the commercial invested more in leaves, which is the photosynthetic part of the plant, while the alien enrichment media invested more in the roots. With regards to P, the control allocated more to the leaves, while the alien enrichment media and commercial allocated more towards its roots. A true test of a soil enrichment media is to look at the correlation between biomass and nutrient content. We did a correlation study between the primary nutrient content and the biomass of both total biomass of both maize and P, and the only significant positive correlation was between phosphorus and the biomass of maize. Root to shoot ratios. These ratios are an indication of plant health in the study, and a lower ratio equates to a healthier plant. Maize plants of the commercial treatment exhibited a lower ratio than other treatment. However, in P, all the alien media exhibited ratios that were comparable to the commercial, except T2, which is Acacia and Hedychium, which had a higher ratio. Performance matrix. This matrix represents the performance of the alien enrichment media compared to the commercial, with the green circles indicating a performance similar to the commercial, while the red circles indicate a performance poor compared to the commercial. As you can see, T1 has performed well for both maize and P, and T3 has only performed well for maize. In conclusion, no allelopathic effects were noted on maize and P germination. Certain combinations did result in a growth that is comparable with the commercial, being the best in T3, which was the Litsea and Tithonia for maize, and T1, which was the Acacia and Tithonia for P. Positive effects of compost differ between C3 and C4 plants in terms of germination and growth, with maize performing overall, with maize having an overall better performance. So we suggest that composting of certain alien species may be a viable option for the disposal of their biowaste. I'd like to thank the following people and organizations for their help in the study.